Hey everyone, Miss Soli here with another lesson in Unit 3. This is 3.3, inverse and joint variation. Okay. So last lesson we talked about direct variation. So y equals one constant number times x. They're increasing geometrically the same way each time. If x doubles, y doubles. If x triples, y triples. So with this next lesson here, inverse, the opposite thing is going to be happening. So inverse looks like this. Y equals any constant k, that's the same, times 1 over x. So this is still any number and then it's multiplied by 1 over x is the same as divided by x. So it's whatever's happening multiplication wise, the opposite is happening to the x. For example, and we would write this: y varies indirectly to x, or y varies inversely. Same. And you could flip those around too. The same thing as x varies to y as y varies to x. Okay, so for example, let's say I have y equals 2 over x. Now, break this down for a second. Really, this is like same as 2 times 1 over x, right? I could kind of break that fraction apart or put it together. Okay, so if I were to make a little table here, with some x's and some y's. Let's put in here 1, 2, 3, 4, right? Something like this. And let's plug everything in. So if I were to plug in 1, 2 divided by 1 is 2. 2 divided by 2 is 1. 2 divided by 3, 2/3. And 2 divided by 4 is 1/2. So let's take a look at kind of in the same way, like the x side and the y side. How do these numbers vary from each other? So looking here, if I go from 1 to 2, I multiplied 1 by 2 to get there. I doubled from 1 to 2. What happens from 2 to 1? Oh, it divided by 2. It did the opposite thing, right? If I go to 1 to 3, right, I tripled from 1 to 3. I tripled what I had. And 2 to 2 divided by 3, I divided by 3. So whatever happened over here to the x's, the opposite happened on the other side. Also here, like from 2 to 4, yeah, you doubled from 2 to 4. So times 2. How do you go from 1 to 1/2? You divided by 2. So whatever's happening on the x side, the opposite is happening on the right. From multiplication becomes division. Then you'll have something also called a joint variation. And this is just when you have multiple variations happening at once. Multiple variables, all varying at once. So something like this might look like, for example, y equals x times z divided by w. See how there's kind of 3 different variables happening on that side. There could be numbers too, could be anything. So in this case, what I want you to look for is imagine only one variable at a time, y to x, y to z, and y to w. And when you're going to just single out x, imagine that these two are constant numbers. And when you're going to just zone into z, imagine these two are just constant numbers. And when you're going to zone into w, imagine that these two are constant numbers. So let's figure out how y varies to x. Imagine z and w are just numbers. So y equals x times something that's direct. How about to z? Again, if I were to imagine these two are just numbers, y equals something times z. Now w is in the denominator, though. W is being divided by. So if these two up here were just some number, just like 2, then y will vary inversely or indirectly to w. You can have a couple things going on at once. Another example could be, I'm trying to think of one with a significance. Let's see, like area equals pi r squared, or sorry, volume equals pi r squared times height. This is the equation for a cylinder, right? So you're looking at where are the variables? Are they being multiplied or are they being divided? And in this case, they're all being multiplied. So V is going to vary directly to R and H. If I were to move this equation around like I did with the other X and Y, like let's say I just wanted to find R squared. So I'm going to divide V divided by everything else, pi times H. Okay, so now R is on the top, V is on the top, but H is on the bottom. So R varies directly to V, which we kind of already knew that, but R varies indirectly to H because H is in the denominator. So you're just looking at where it is compared to the